Hey everybody, John from Additive Alliance here, continuing my series about how to build 3D printers. Today's video is about building a solid frame, an often overlooked and underestimated piece of a good printer. To build a good frame, you need to have the right materials and the right layout. It should be stiff to be able to handle the shakes and wobbles that the motion is going to throw at it. And that way you can actually keep a good looking part and handle the environmental constraints such as covers, so that it is going to be able to work with a lot of different materials. I have a bunch of different props I want to talk to you about, and then we'll actually get into the layout on the machine. So let me turn the camera around and we'll look at those first. Alright, so here are a bunch of pieces of frame that I have just for example. This is the actual extrusion I used and settled in on. This is 2020 rail, so called because it's 20 millimeters across and 20 millimeters down. You can buy it in different sizes like 2040, obviously. See what that is. Plus a bunch of other sizes. You can go in 30, 30, 40, 40. But typically the connection hardware is going to be easiest if you stick with one continuous size. What's important here is the type of rail, the profile of it. If you look carefully, this shape on this top part is a V, and you see that on all four sides versus a T. A T is flat right here. And you want the V because that gives you more flexibility in the type of connectors you can use, and it also allows the type of palm bearings that we'll be talking about later in the mechanism to be used quite conveniently. I use the 4040 for the actual bearing surfaces. I'm sorry, the 2040 for the bearing surfaces, and that works quite well. Then you see in front of me a bunch of the connectors, corner connectors that we use or don't use in the case of this particular one. This is a generic type of corner connector I tried and did not like it because it is not positive locking enough. It's just a little too sloppy. If you shop around, you can find better versions that have these locking tabs that fit into the 2020 rail like that or like that. This particular one, as you can see, has a hole here so that it mates up against the other rail like that. But it also has a secondary hole so it can actually mount against a rail like that if you need to connect it in an odd angle. I avoid doing that on the production level units, but if you're prototyping something, boy, that sure is handy, and it really doesn't detract from the look of the unit. Other connector types available are this style. So if you need a oblique corner where you don't want anything protruding out like that corner angle, you can use something like this that fits very tightly into the corner. They work quite well. They don't provide quite as much stiffness, but they're not bad. I use them in a couple places around the doors. And then if you're doing a real compound corner, you can use something like this. You can find these in a whole variety of shapes, whether it's a four-banger like this that holds three 2020 rails together, or even a 2 version or a 3 version. There are a whole bunch of different ones, and these just fit together like that, so it makes this nice little corner, and then other rails can fit onto it like that. And as you can see, you could put one here as well. So that's a rundown of the corner connectors. Now you realize that each one of these connectors is going to need some way to actually physically attach to this, some kind of a screw or clamp to attach to it. These guys come with set screws that just run in here, and they will tighten up against the rail through the set screw hole. So that's a threaded hole, set screw goes in, torque it down, it mounts pretty nicely. It's the same with this version. Those are threaded holes right there for a set screw. These guys are a little different. These are just through holes. So they will need a nut on the rail somewhere to be able to mount, but that's also what kind of gives it the flexibility. And there are a bunch of different types of nuts available. Here's a very simple version. It is not fancy at all. It's basically a profile that slides into the V groove, like so. And then you can actually take a screw, and if it stayed in place, and screw it in there. Of course, that would be through the corner piece. So you get the idea that it works like that. But you can see the problem with it is that it slides very easily, and you can only put it in if the end is open. In other words, you can't put it in from the face. So anybody who's done this before might realize that there's another type of nut available that looks like this. You can see it has a funny little profile where you take a screw and you can start it on the screw, and then take it and actually just slides right into the rail like that. And when you tighten it, it actually spins, at least in theory it spins, so that it clamps. So in theory it spins so that it becomes a profile like that. I don't know if you can see all the way in there, where it now will not pull out. And these are pretty cool, but they suffer from two problems. One of them, you can't always guarantee that they spin. And if you do back it out all the way, there's nothing holding them in place. So if you're on a vertical rail, it just is going to fall out just like that, and you're screwed. So what's the solution? Well, there's yet another type of nut that you can buy that looks like this. And it has this little spring-loaded ball bearing on it. It's not actually a bearing, but it's a spring-loaded ball. It acts like a detent, kind of the way you would have on a socket wrench. And it allows you to snap it into place so you can put it in from the side and then snap it down, and look at that. It actually holds it in place because that little ball adds resistance, and then you can thread right into it like that, and it stays in place, and you can take the screw completely out, and the nut still stays in place. They work pretty well. However, they're not perfect because of the fact that you can actually put them in from the side. If you're slightly misaligned when you're tightening or loosening, they will go askew, so that when you actually back it out, they wind up like that, and then they fall out. The solution that I came up with for this is a bit simple, albeit a bit onerous if you're doing 100 of these nuts, and that is a piece of 1mm foam. This is sticky on one side, but I don't even take the backer off. I leave the backer on there and insert it into the slot, and then make sure I have my nut positioned in the correct place, and it adds just enough resistance now so that it will not slide. You have to have either another nut or a tool to put it in, but once you put it in like that, this is not going anywhere. So you can see there's a backer in there. This will not slide for anything. And it will not, if your screw is coming in slightly misaligned, it will not unseat the nut. So the nut stays in a great position, and that's what I wound up using on this machine. It's highly effective, and I think it works great. Now let's take a look at the machine itself. Okay, so let's look at how the machine itself is laid out. First, we'll take a look at those connector pieces we were just talking about. So you can see where my hinges for the door mount. You can see a little piece of foam. You can see a mark. I use a template to lay out where the nut hole is going to be. And so there's the foam, and there's the nuts that are pressed in, and they do not move. They are in there nicely. Here's an example of one of those compound corner connectors, because I need the clearance for a door here. And you can see up top here where I use a lot of these corner connectors. They're my preferred connector because they provide significant rigidity. You can see on this corner I actually do redundant connectors. There's even a redundant rail here for some different reasons, but rail is cheap, and so when the layout of this frame is easier for the flexibility to add a dual rail here than it was to try and reconfigure this to be a single rail on this particular machine. But anyway, so you can see how all these corner connectors work out. Down here underneath this rail is actually one of those single elbow connectors, and that's used because I need the clearance for the cable egress here. Now, looking at the machine, when you lay out a frame, the consideration is that you want it stiff. You want it to not be able to twist this way, or this way, clearly in the X, Y, or Z. And what prevents that is a shear panel. So this is a piece of sheet metal, and those of you doing a home printer may say, that looks too intimidating. Yes, that was professionally made. I designed it on CAD and had it made. But it is really just a piece of flat sheet metal with a bunch of holes in it. And it doesn't take a whole lot of holes. I mean, you need at least 3 per rail to grab it. The rails themselves even have the corner connectors, as I mentioned, underneath to locate them. And that prevents any twisting in this direction. So that stops all the twisting in that direction. And if you're building a printer, you're going to need something to mount your electronics on. And so you see another shear panel, which is this piece. You can see it from this side, which again prevents twisting in that direction. So with the 2 shear panels, we've effectively triangulated those 2 directions and stopped any twists. This particular one has a bend in it. I put a rib in here for some different reasons. It doesn't have to be there. It can be a flat piece of sheet metal. That would work fine. Then you need to be able to have something to mount covers on, and you need to be able to stop the rest of the twist. And that is mostly done by these 4 pieces here, here, and here, to stop twist in this direction. But notice also that the frame really kind of triangulates. I know it's square, but using these, this surface and this surface. So see how these guys help stop the twist out at the outer side. The way I happen to mount this X rail, using those as well, acts as a stiffener for the frame. Now that I have 3 pieces, that effectively gives you a type of triangulation, not in the pure sense, but in the sense of stiffness. The front would love to have a diagonal cross piece on it, but that's hard to do when you have doors. So you need the access, and that's the whole goal. It's like having an open door on a car versus having a roll bar cage going right across the front. It's not easy. So that's the way you lay out the frame to get the maximum stiffness. You lay it out so that you can get the covers on it, and in this case, these extra rails provide space for the environmental enclosure that goes on it, as well as the enclosure for the electronics. All right, so there you have it. That's how the frame of the NX3D is laid out. The important considerations are what kind of rail to use, how you're going to connect those rails, the type of nuts you use that will meet your requirement, and make sure it is as stiff as you can figure out how to make it. If you have any questions, hit me up. If you have comments, smart remarks, I'm open to all of it. Love to discuss it with you. Cheers.